So looking at page 72, the last topic here, the focus is on the two-way chi-square tables. General same structure as the previous one, right? Independence, goodness of fit, probabilities are the same, probabilities are different, or no association between the two variables, row or column. That's the extra. That's the new one for this particular test. Everything about alpha is the same. The critical values for the chi-square table, degrees of freedom. Degrees of freedom is different. I'll get to that in a minute. And then a lovely formula that we won't have to use because we're going to do it in a calculator, and it's still a chi-square distribution. All right, so chi-square dist. The null hypothesis says at the 0.05 significance level, so my alpha 0.05. Test the claim that there's no association between the row variable and the column variable. All right, so no association between pass, fail, and math course. So I took the table from, I think, 2 or 3 pages ago in the packet, and I just got rid of the 2H category. Right? That was, so we had the remedial, the regular level, and then the honors level. It didn't seem like there was any kind of question about the honors level. Everybody passed. It's an honors level course. You'd like to think that that would happen. But we did have this group of remedial students where most of them failed, whereas in the regular level, most of them passed. And then we just want to see what the interaction is between these two. Basically, it's kind of getting at the idea of, like, is one variable a cause of the other, right? So if I am a 2A student, am I more likely to fail? But then you look at it and say, well, am I in the 2A class because I'm more likely to fail? We don't know, but that's where the analysis comes into play. The alternative is that there's some association, I'm not going to make you rewrite the entire sentence, between pass, fail, and math course. So some association, ... is good enough. My degrees of freedom is the number of rows. So we have the meat of the table here. We don't include the totals. There's a 2x2 table. All right, so number of rows that we call R creatively, and number of columns that we call C. Degrees of freedom in this case would be number of rows minus 1 times number of columns minus 1. And so 2 minus 1 is going to give me 1. So 1 degree of freedom. That's what goes right in the middle of the hump there. Here's my 0. Somewhere over here associated with the 0.05 is going to be my critical value for chi-square. So let's go to the calculator. Under inference tests chi-square, you have goodness of fit, which we already did, and homogeneity and independence. So you'll see it's broken up in tabular form. Group 1, Group A. So I'll just type in the numbers. We don't have a Group C. It expands it, which is really nice. It expands the table if you have more values to put in than just a 2x2. All right, so we're good there. Even though it created a Group C and Group 3, it didn't populate it with anything. So I go to next. It gives me the expected value, so I'm going to jot those down. In the table on paper is what we had. On the calculator screen here is what, based off of the interaction of the variables, we should have had. So the chi-square test is going to determine whether our values are so far away from what they should have been that it creates some sort of association between the two variables. Or are they as they should have been, in which case there really is no association between the variables because that's how nature dictated everything should play out. All right, so I hit OK. And by the way, before I do that, it's nice to have this sight recognition that the numbers are generated properly, because the totals for your expected should be the same as the totals for the raw data. So my 10.95 and the 5.053, they do add up to 16, or at least something that rounds to 16. So we're pretty confident that we didn't just botch the data entry part of it. Right, so all the totals bear out properly. Right, so my chi-square test statistic is 7.785, p-value 0.00527. That's very small p-value, so I'm going to say reject the null hypothesis. I do need this number, so we'll get that in a minute. Degrees of freedom 1, which is what we knew. Oops, sorry. Then I'll go to next, take a look at the picture. It only shows me the right tail, but that's good enough. I know my cutoff should be somewhere south of 4, but we need the precise value, or the most precise value. So I go to that table that I referenced on a few pages ago. 1 degree of freedom with an alpha of 0.05. So 1 degree of freedom, 0.05 is going to give me this 3.841. And so 3.841 is my magic number here. Right. So I'm rejecting the null, so that's out. Alternative is in. So there is sufficient evidence to cross off insufficient. Apologies. There is sufficient evidence to reject the claim that there is no association between whether a person passed or failed, and math course at the 0.05 significance level. That happened to be what they were asking again, so I can get rid of that second sentence. But we think about what this means. There is sufficient evidence to reject the claim that there is no association. So that means that there is some association. They didn't really ask us that, but we're just kind of thinking it through. There is some association between those two variables. So whether you pass or fail is impacted by whether you're in 2A or 2, and vice versa. Whether you're in 2A or 2 may be impacted by whether or not you typically pass or fail. Right? So it's really the beginning of the conversation rather than the end, but it's enough evidence to say that the conversation should move forward.